What's up, guys? Let's take a look at another CodeWars exercise. This one's called Who Won the Election? We get a bunch of ballots, which are very simple, just a name. We don't have ranking, we don't have categories, we just have a string. And then we count them all and see how many each name got. If someone receives over half, that's the winner. If not, we return none, is the Python version of null or nil or nothing. Now, in theory, we could do this on our own, go down the line, and we see a name and we think, if I've seen that one before, I add 1 to the count. If I haven't, I start a new count for that name and I started at 1, and then later we can look through the counts and sort them and whatever we need. But Python has a lovely data type that does just that. It's called counter. And if you go from collections, import counter, then you'll get it. The counter is a dictionary, so it has all the dictionary functionality and methods that we come to know and love, but it has a few more, including one method we're going to use today. So let's start off by saying print counter of ballots, and this will show us what's going on before we use it. So it says A1, because in that first test there's a single ballot with just A. And then the next one, it's got 7. A has more than half, so A should be the winner. And then the next one, it's even with 3 and 3. And guess what? We just happen to pass because the default return in Python is none, and sometimes they're looking for none, so we're passing some of the tests even without trying. Now, how can we sort these, filter these, whatever we need? Basically, we're going to use just one method called mostCommon. And if you say counter.mostCommon, it looks about the same. We get a name or whatever the key is, and then the count. But instead of this counter object being dictionary-like, instead it's just a list, and it's organized greatest to least. So the top vote getter will be first, which is not how it is normally. Normally the first one we saw will be first, and that's the tiebreaker in this case if you had a tie. mostCommon by default shows you all of them, but since we only want the top one, we can put a 1 and narrow it down. We don't have to worry about a tie, because if there is a tie, like that 3-3 example earlier, then we definitely won't have a winner, because you have to have more than half, and there will never be a tie with more than half, because then the total would be higher than the total. Now, what I'd love to do is just name them from here. I'd love to say, like, you know, candidate and votes equals that, because we're getting a tuple, we're getting 2 things, right? So normally in Python you can say, hey, let me destructure that, or let me unpack that. But if you'll notice, a minute ago it wasn't just a tuple, it was a tuple inside of a list, because the mostCommon puts this in a list very sensibly when we have more than one, but in a kind of annoying fashion when we have just one, because we have to like peel open the layers. So how can we handle that? Well, there are a couple ways. We could say 0 right here to get the first thing out of the list, aka the only thing out of the list. Or we could say dot pop to pop off the first thing or the only thing. Or we could wrap these in the same pattern as we get. So if we say, hey, there's a list with a tuple, and we name them, then it matches, hey, there's a list with a tuple, and we name them. So any of those makes sense. This is what you would do in a pattern matching scenario. But since we're so simple here, we only have to do one thing. It's probably not worth starting a whole pattern match section. But let's say, okay, if votes is greater than half, so I guess I'll say ln of ballots over 2, and maybe I have to decide, should it round, should I add some parentheses? I think this is enough right here. We'll give it a shot. We return candidate. And hey, there we go. I think that's enough to pass everything. Yeah, because this will trigger on the ones that qualify, and then Python will return none by default on the ones that don't. You might want to be explicit and say, hey, I'm returning none a lot of the time, because if someone looks at this, they might very reasonably expect an answer and sometimes get none, and then they would mess up their whatever they do with the result, you know? So we might rearrange this to say, like, return candidate if votes are enough, else none, which is to be more clear and say, hey, you're getting a none sometimes. Be ready for it, buddy. Some languages will build that into the function signature, the function definition, and Python can if you have a little annotation, but it's not there by default. So let's do what we always do and check the solutions from other people. They might have the same thing, or they might have some nice ideas. First one, very similar to ours. They used the index to grab the tuple from the list. They put the else none, which is probably what you want. This person looked through the list and said, hey, if I find one that qualifies, I'm done. So you might think that's more efficient, but doing the count method loops through every time, and I don't think they cache it and remember what they did last count. So this probably ends up being a little slower, even though you might say, well, hey, we could finish the job when we're only 60% of the way through if we've seen that somebody got so many votes already. Kind of like on election night when you're watching TV, they'll declare it before they've counted literally every vote. If you can see that like one person is ahead by enough that we're pretty sure, they'll still end up counting the other ones later, but you might know beforehand, you know. However, this is not quite the way to do it if you're going for ruthless efficiency. Here's one that gets a counter, and they use the pattern matching, and in fact the person just said, hey, I'm doing this for fun because I'm trying to learn pattern matching. And they could add another case. If you put case underscore, that's like the else, that's like the otherwise. To make it really clear, you could say case underscore, return none. Similar thing. We're probably going to see that. Oh, look, there's a statistics module which can do some work for you. And mode is the thing that's most common, right? So they can use that as a way to get similar functionality to our counter. This ends up giving you a counter, but like I said, it's less efficient because it counts again every time you give a new value. It says, let me start over and start counting, whereas the counter goes once through the whole thing and keeps track of all along the way. So if we kept scrolling long enough, we'd see something really surprising. But for now, I think the solution we went with, or if you wanted to be really strong, you would use the pattern matching with an extra case for the none, is great. We're going to use counter a lot, so it's good to practice it. There you go.